Good morning to everyone. Today we'll be doing a video presentation regarding our Capstone project. Members of our group include me, myself, SAKULKAEW, which is the project manager on this group, Mr. Pattarapon Buathong, which is the data engineer, Ms. SUCHADA, PANYAWIRAPHAT, which is a production analyst, Mr. THAWORNSKULCHAI, which is our software engineer, and Ms. PAWORNRAT, which is our financial analyst. Now, first things first, we'll take a look at our overview here. The software which are used here, we have Excel, which is part of our data collection part, AnyLogic, our simulation part, OSI Soft PI, .NET MVC, our admin dashboard, Power BI, HTML, CSS, JavaScript, and MATLAB. Now, first off is our overview. If we look at our system architecture, first thing first, you see here is our distribution and MATLAB here. This is basically the information that is given to us by the question and the distribution of previous models that we have. We have analyzed, first things first is we will analyze the data which is given here using MATLAB and Excel itself in order to create a simulation on AnyLogic. AnyLogic here will substitute our real-life counterpart, which is the actual pump station, and it will simulate all the actual trucks moving in, the variations in time, as well as some delays in repairs and maintenance. Now, after we finish our simulation with AnyLogic, the data is exported as an Excel file into our PIA, which is the data archive and collection. This is part of the controller of our application here. In this part, we also can use PI Vision to pull a report directly using the PI Vision here. Now, part of our application, we use the SQL Server as our backend here, and we are able to pull data from the SQL Server as our financial report here. Same thing, we use the basic tool, which is basically the create, read, update and delete part. As for our front end, which is where our user will be able to view the system, is written on dashboard using HTML, CSS, and JavaScript.
This part is about IDF0. IDF0 will show you about the method and detail about the terminal automation system, or we can call it task for operator. Understand more and make less mistake of the filling process. In this project, the perspective of IDF0 will be driver, cell, and task. In part of task perspective, we'll show the all process of terminal automation system from beginning to the end. Start from task will arrive at the petrol station, going to sales office for check the PO from the customer and identify themselves. After that, truck will travel to the waste station to weigh the empty truck and go into the base station for filling process. At the end, the truck will go into the waste station to weigh the filling trucks and leave the exit gate. In this part of the driver perspective, we will show the process of the driver from the beginning to the end. Start from the driver, arrive at the sales office and swap card, ID card with the card reader and check the PO carry in the truck to the waste station. After that, drive the truck to prepare the filling process by safety instruction and install the safety equipment. After finish all the safety equipment, you go to the fill the gas, and at the end, driver will drive the finished truck out from the system. In part of sales office perspective, we'll show the process of sales office from the beginning to the end. Starting from the sales office, checking the document of truck by PO and driver ID card. After truck going to the fill process, sales office will approve the purchase order and wait to create the invoice according to PO and ending the process.
Okay, so for this part, we are going to take a look at the AnyLogic simulation, which is a simulation of the process of filling up gas or diesel according to the purchase order given on each truck. Now, first things first, from the previous data that we have received on the Excel chart, we were able to analyze the different parts and the different values that are needed and the different distributions based on the real life counterpart. Now, first things first, I'll explain here. These trucks are started by the source, created by the source. In which case here, this is where the truck enters our simulation. It enters at an exponential of 1 over 14.3521, which is based on the distribution given on the Excel chart. And it arrives at the model start. So that means that at the start of the simulation, the first truck will arrive in order to minimize delay in the simulation. Now, in this case, when the truck starts at the source, we have, let me go back here to the first truck. This is the agent, which is basically the truck. We have different variables which we can keep and we can assign values to, which will help in our simulation. Now, the first value which is assigned is, as you can see just now, the purchase order number, which is basically, in this case, just an assignment in order to identify each truck from each of its counterpart, which is basically a counter. So each truck will be number 1, number 2, number 3, and so on. Now, after the truck is created, the fuel is designated at a probability of 0.838. This 838 is also a variable which is calculated from the Excel, which is the amount of diesel trucks to the amount of gasohol 95 trucks. So after the truck passes through the fuel designate, which is immediately after being created, they are assigned a value of 1 or 0, which is correspondent to both diesel and gasohol 95. Now that we have a truck that is designated with a purchase order, which is similar to what we will have in real life, with a percentage probability of 0.838. Moving on to our sales office, first thing that the truck will encounter is the triangle design time of 8 to 10:15, which is basically given in the question. And we have the first of our few information. We first here have details of the arrival time and the service time, and also the departure time, which is kept in this process. On enter, which is basically when we enter the delay, we keep the arrival time. On enter delay, which is basically when we enter the service. So basically the time between enter and on enter delay is the waiting time. In this case, our first truck does not have the queue, so that is why we are able to skip this part. We are skip this part for the first truck and move exactly onto the service time. As for first service time, we have a delay, like I said before, 8, 10, 15 triangular according to the question. And here is where we insert the data into the Excel. I'm going to show you the data. I'm showing you the configuration for the database at the end here. We have a delay, which is basically the travel time for a truck moving in between each of these systems, each of the processes. And we have parking after sales here, which usually is not used because the trucks usually move on directly to the base station because there is rarely a queue. Now, a delay time for another traveling between stations. And next we have the sweet station. So according to the question given is that after the truck moves into the sales office to sort out papers and documentation, the truck needs to wait first. Now, in this case, everything as before, we have agent arrival time, service time, and departure time, which gives us our service and wait time if we subtract it later in the Excel report. Now, for this part, same thing we insert here. However, the thing that we have added in is the agent weight. Now, this is given as a uniform distribution of 10,000 to 15,000 to simulate the different weights that is possible with different trucks. So it's on a uniform distribution, and it is randomized for every truck. increasing the realism here. Now, here, similar to before, we move on to delay, which is part of the travel time. And here is where we separate the trucks from diesel and gasohol. Just previously in field designate, we have already assigned the value according to the probability of 0.838, and therefore we are able to use that value to separate one for gasohol 95 and one for diesel. Once we move on to service, I'll let you take a look at gasohol first. We have calculated the distribution time of beta here, and values according to the data given from the truck log using program tools such as Excel calculation and MATLAB. And same as before, we have the service times and the waiting times all recorded. And here is where we have the agent volume. So we take departure time and arrival time, subtract it and multiply by 200. That is in order for us to get the value which is used when we pump the amount of volume into weight station. There's nothing much here. Same thing in diesel. Here we calculate the distribution of beta as well, slightly different number, and same thing. The amount of volume is calculated based on the time. Another thing to take note of is when we have failures. Here, one moment please. We can have failures based here on the maintenance time, which is part of, it's part of here. There's a compartment. Here. Basically, we can start initial time to failure. It's calculated at 150 hours, which is an exponential of 1 over 150 exponential 0.01111. Now, the repair time, according to the questions as well, translated into an exponential value, and that is the same given to gasohol 95. So this is basically pulling the resources. So basically we have a process here and we pull the resource of each gasohol compartment. Next we have a delay time of 3 for the time that is used. And as given in the question, before we exit, we also have to have a wait service to calculate. In our simulation, of course, we use the previous volume and multiply the density in order to find the weight per kilogram. So basically, we have a volume of 1, perhaps 1 liter of fuel would be equal to 0.85 kilograms. So the respective fuel and weight is given for each type of fuel. And same thing, the data is all exported out. Now, finally, we have a delay here to simulate the exit, and we have the sink, which is where the truck in our simulation gets destroyed, but translated to real terms means that it exits the process. Now, here quickly is a rundown of our resources. We have previously diesel and gasohol compartments. Here's also the scales for before and after. Sales officer here as well as in our sales office. Now, moving on to our database first. Once all this information is collected, you've seen here previously in the insert into tables. Those are run into the database, which is seen here at the bottom left. We have different timetables, and those timetables are exported into an Excel, which we will take a look at later once we run the simulation once. Once we set up the simulation, we use the data to export into the Excel after each table here. Now, once you run the simulation here, One moment, please. Okay. Now we have a running simulation. Let me move on. So virtual time. Okay. As you can see here, this is after it moves on for a while. Basically, let's slow this down a bit. Explain. Okay. So basically, this is a simulation here. A truck enters at the source here, will resonate, and moves on. Each of these bars represent a process. Now, it is being moved at a fast pace, as you can see from the time up here on the bottom right, the top right, sorry. You can see that processes moves at for every time that a truck moves into one of the services and everything, we have resources being taken. Here is a quick view of our 3D simulation. Sorry, mouse is not quite good. Yeah, simulation of 3D going through the system, and that is basically how the systems run. Now, right now the system has been running for 4 days. Now, in order for there to be some value, well, technically there is already value being exported to the Excel, but I'll run it for approximately 30 days, which would be almost equal to the amount of time which is given in our data previously on the given Excel. So now it's 21 days, 32, we'll wait for 30. Okay. Now that we've done with the simulation, I've pressed stop. That means that the data is all exported now into Excel. That means that one moment, I can open Excel. Here. And take a look at the simulation data here. As you can see here, this is our data. First things first, let's take a look at the field office. As given, we have arrival time, departure time, and service time, which is calculated because this is a new Excel file. The previous values that we have calculated are missing, but it's a simple process of basically subtracting the arrival time, service time, and exit time to get our waiting and service time. You have different PO numbers, which is basically the amount of the identification for each individual truck. And we have approximately 3,000 trucks which have run through our system, which is almost equivalent to the given data previously because we might have overshot by a day. But we have roughly the same amount, so that proves that our distribution of the amount of trucks arriving is relatively close, if not correct. Okay, after the sales office, we first go to the weigh station and load it. Here, same thing. You can see here, now there are some variation now. Some trucks go in faster, some trucks go slower from the runtime. Same thing. We have the times, you can subtract, and we have the weight given. It's uniform distribution here. Then we go through each individual downtime of each individual pump. Here we can separate gasohol and diesel here. Now remember when I mentioned about downtime, those are also given here, and each start failure is recorded, and once there's a repair, it's correspondingly given. So here, failure and repair. We have 2 failures before 1 repair is given, and another failure before we finish the other previous repair. So that means that there's a total of 3 failures and 3 repairs, both being done at separate times. Same thing here, gasol down 5 downtime. Similar thing, 2 failures, 2 repairs, and each individual failure has a repair, corresponding to the time given. After that, we have switch station loaded, which basically take the weight after filling up. You see, the weight has increased from the previous weight here. Here is around 10,000, 10,000, 11,000. Here is around approximately 20,000. After that, we all have the exit time, which is basically the time that each truck exits. And we also are able to calculate the time is use space truck. So basically we can pull out the arrival time and sales office to the exit time to find the total time given for each truck. And you can also pull out different timestamps in order to find the duration of each simulation. So that is a basic rundown of our AnyLogic part and the simulation, and we have received the data into the Excel. After that, we'll see what we do with it next.
This is the PyTech part. So we begin with PyTech coding. There's going to be structure hierarchy you see here. We start with plan ID. I will call it A001. Next is data source ID. Next is area ID. And the last one is tag name. First one is O01, the loading automation of group 1. We have flow transmitter, temperature transmitter, a level transmitter for the diesel and gas turbine, that is according to AnyLogic. And we have filling volume for the filling station. We have the weight of the inbound truck and outbound truck. We have the timestamp of the arrival of the and departure time of each station. And we have truck ID and PO number of the order, and of course we have the arrival time and departure time of the filling station. And we have the other areas such as loading operation, costing API, service performance, OE, and service monitor. So the S03 service performance, this will be shown in the dashboard. This will be used in the dashboard via the PyWeb API. And we have average waiting time, truck in, truck out, average cycle time. We have schedule utilization of weekly and monthly. We have the fail time, daily stock, and so on. That is a requirement of the operation and manager dashboard. And the OE part, S04, we have OE, A, and P of the diesel and gasoline station. The A is availability and P is performance. To upload the data of value and timestamp to the PyTag, first we need to copy the PyTag that we made and created it first in the PyBuilder. So we have the PyTag name here and the description here. We choose the start value as future data and the point time. So we have in our data have float and string and timestamp. So when we created the Py point, we have to shoot this correctly. So after we got the data from the AnyLogic, we will manipulate the Excel so we could have the correct data that we will upload to PyTag here. So in the PyExam 64 that OCSoftPy provided, we paste the timestamp that we want here. For example, this is the daily timestamp and the value here and the PyTag here. And we need some settings. So we go to developer, Visual Basic, and we scroll down. So you can see that the number of data is 30. So because we have 30 rows, and the S-tag name means the PyTag, we set it to the 4th row and 3rd column. So it takes only this cell when uploading. And next we can make sure that our Excel is connected to the Py. Click on the current value, click search, and click search again. So see, we still haven't logged in, so we will log in here. After we see the result, So this make sure that our Excel connected to the Pi. We can click send upload value to upload each database into the Pi. So after we did all the uploading, we will click search on the Pi builder, look for our group. We have group A1. So for example, cell office arrival time, I will select this. We can copy the Pi tag here, go to data, archive editor, paste it here and change the time to last 5 years. So you can see that in this case the value of this Pi tag is timestamp, and the timestamp is timestamp as well, so it will be the same value here. So this is the Pi data archive part. So we can take a look at the data that we want. So we could select and click OK. So here we can see other data. So after we upload and check the data of each Pi point, we will create the hierarchy in the PIAF right here. So we open the Pi System Explorer software. This is our group, then check group 1. So for example, let's go into bay loading here. Go to detail bay 1 and let's go to O1 loading automation. So if we click on the attributes, you can see the Pi tag that our group assigned to the detail bay 1. So in order to take a look, we have to log in 2 times. Okay, so you can see that here's our Pi tag and the IP. So it's all listed here. In the detail bay 1 we have arrival time, departure time, filling volume, flow level and temperature transmitted. So it will be the same in bay 2 and bay 3 and so on, but it will be different Pi tag. As you can see, we have inbound weight bridge, so it will be different kind of value because this one weighs the truck in, the outbound weight bridge weighs the truck out, and so on. So after we create the hierarchy in the PIAF right here, we can create the report, the dashboard in Pi Vision. So if we go to Denchai group 1, which is our group, go into this dashboard. Okay, zoom out a little bit. We could see the data of each sensor here and the offline online value, which bed is, and if you look at the time, it will be 1st of April. So we can choose like 1 hour back, the data will change, or 1 hour forward, maybe 1 day forward, so it will change every day. So the data will change because if you take a look at this one, if you take a look in the PIAF here, then check group 1, bay loading, disable, or 1 loading. So we can select the visualization time. For example, these are values, and we drag and drop this into the dashboard. We can get this value according to its Pi tag and value and timestamp. So that is the Pi tag here. So in manage dashboard, there will be weekly dashboard and monthly dashboard. In weekly dashboard, the data display will be pulled from the private API of the weekly Pi tag. So we can see the weekly diesel volume, weekly gasohol 95 volume, weekly average diesel cycle time, weekly average gasohol cycle time, average waiting time at each station, number of fail time at each station, schedule utilization, and number of truck in and truck out. In the monthly dashboard, the data shown here will be monthly data. So for example, monthly diesel volume, monthly gasoline 95 volume, average monthly diesel cycle time, average gasohol cycle time, and so on. It will show the data of the monthly for the manager to analyze. This is the demonstration of operation dashboard or daily dashboard. So we will have daily diesel volume, daily gasohol volume, average diesel cycle time, average gasohol cycle time, average waiting time, number of fail time, and number of truck in and truck out. So let's change the date. So each value will change according to the date. So you can see there's gasohol 95 day fail time 1. This page shows the line graph of fuel stock inventory here, and it pulls data from PyWeb API. So we have daily diesel inventory stock that tells at the end of every day from the first day to the 30th day how much diesel in the inventory that we left, and it's also for the gasohol 95 as well. So the line graph will tell on the y-axis, it will tell the lits that we have left, and on the x-axis it will tell the date in the month. So if we place the month here, you can see the dots that shows the value of each day of diesel, and the daily of gasohol 95. This is the dispenser-based OEE report of Group 1. So we take the data from the Pi using the Pi data link. So you can see each cells, we have different Pi tag, but the Q in our condition, it will be 100% of every day. So we didn't put it in the Pi tag. And the bar graph will take the value from here and show. So let's try to change the date from 10th April to 15th April and watch the value changes. So you can see that the OEE of this survey becomes 100 and the OEE of gasohol 82 becomes 68. That is because on the 15th of April, there's no failed in the survey one, but there's 1 or 2 failed in the gasohol base station. You can see the bar graph here. This is the PyWeb API part written in .NET MVC. So we have Pi controller here. First, we're gonna declare our username and password that used to log in each OCSoft Pi system, and we will use the HTTP GET method to get the data from the private API. So, for example, get diesel oil daily. So this method will take the date time, select date, and will be declared in the URL here. So first we log in. This is the method of login, and we find the day that we will use into our item URL here. So this will replace the start time and end time in the URL, and each part tag will have special of web ID here, and it will be different in every part tag. So it will receive the response from the API URL. It will create the result as the tag value model here. So as we've seen before, in each part tag there will be timestamp and values. So this will receive the timestamp and value as well. And if we receive the response successfully, it will return OK, and we will get the data from the web API. So if you receive the Pi web API from here, go to data server, go to points, wait a little bit, and for example, this is our group tag epsilon. It will have web ID that is different in each part tag, and if we specify the start time and end time, it will show the data in the timestamp between this. For example, if we want 1st of the April, this line will calculate how many days from today's that it take back to calculate this, and we will get the data as the JSON file format.
Before we want to access to the web page dashboard, we need to log in first. In this case, we will be logged in as an admin account. After we log in, can be accessed to all the dashboard provided in this website. User can also see their profile through this dashboard. In this case, we log in as an admin. We make the user login and profile part happening by set the model as required, the username, the password, and name. We set display name of the username and name only, because on the user profile it must be shown the data of only username and name. It should not be shown the password. On the login part first, we connect the data from the database and make it check if the username and the password that user input is correct or not. If it's correct, it will show the data of overall the dashboard in the web app. But if not, it will show the error. After the user login, user can see all of their important information of their user profile dashboard, which it will be connected directly from the database as well. If we log in as an admin, it will show the result of the admin account.
This video is for INC382 Capstone Final Project for Automation Engineering. We are Group 1 and we are going to demonstrate the financial dashboard webpage. So we will first log in with the username and the password. To access the financial web page, we click on Finance. Here, we can click on each one of these boxes to look up financial data from the database. First is the General Journal. Here, we can select the date and click Search. And the results shown on the web page are all transactions that occur during the day. Next is General Ledger. We have 4 options to view in General Ledger. First is the cash account. All events that relate to cash will go into this ledger. This is where you assemble all your cash flow information, both income and expense. For the account receivable ledger, we can select a date and search. This page shows the transaction and payment history of each customer to whom the business extends credit to. As for the inventory ledger, all transactions relating to inventory flow, such as buying and selling the gas, will be shown on this page. For the account payable ledger, we can select a date and search. This page will represent a company's obligation to pay off a short-term debt to its creditors or suppliers. Moving on, we have the monthly income statement, which summarizes your business revenue and operating expenses over a period of time. The reconciliation sheet Okay, so this sheet prevents fraud as it notes if the customer has received the gas or not. Next is the inventory stock card. This is a monthly stock card. It shows the beginning stock, the purchase stock and sold stock during the month, and the stock at the end of the month. Next is the purchase order. For the purchase order, we can search for the purchase order of the customer and see how the customer orders the gas. For example, if I search this number here, 25, for the PO number, the page will display the customer's name and how much gas was bought from the customer, and etc. Lastly is the paid sale invoice. So if I type an invoice number, such as this one, and search, we get the cost of the products purchased rendered to the buyer.
We create the financial dashboard part. In this case, we make the form to be separated. The data that very important in the financial dashboard part, such as the general journal, general ledgers, monthly income statement, reconciliation sheet, inventory stock card, purchase order, and paid sale invoice, just as shown on the dashboard. And after that, we create an important model that will be linked to the database. The journal, the ledger's information, all this will be linked to the database and display the data in the web application. We form all the controllers in the financial controller part In this part, it will talk about all the important data that will be shown on the web application. Just like the others, we connect the database to make the code linking with the database, and we select the table that stock the data that we want to show and create the method name to make it link to the web dashboard part. We also stock the dashboard part in the same folder as well. We mention the method name to make it link to the controller and show the model that we want to show. There are different method names that we set to make the program know how to use the data and display on the website. All of this information is directly connected from the database. After the financial dashboard, we will move to the search tab dashboard. In this part, user can see the result of the truck detail by according input the PO number. In this case, let's input 1. It will show the data of the truck to the PO number 1 that we input. Let's change to the number 2. The results will be changed according to the PO number 2 data from the database. Now we will talk about how the truck dashboard working. First, we create a model that required to store the database of the truck search, which will be the PO number, the truck ID, the station name, date in, service term, date out, and time out. After that, we create view to make the website happening display. In this part, we use the method name truck search to make it filter the result. In this part, it will be include the information from the controller as well. Now let's look on the truck controller part. Just like mentioned, we filter the data that will be done on the web page by using the method name truck search, which will be filtered according to the PO number data straight from the SQL database. This is the database connection string that we use. It will connect directly from the database. And after the user input the PO number to see the result they want, the system will show all the data according to the PO number that the user input.
This is the Excel spreadsheet that we use to calculate for the financial dashboard. Following the given criteria, such as truck data log, prices, expenses, amount, beginning and safety stock, purchase lot, and AnyLogic simulation data, we were able to calculate for pages such as the journal account, the ledger accounts, monthly income, etc. The calculations were mainly a combination of the commands VLOOKUP, if command, and basic mathematic operations. For the inventory flow of diesel in PO diesel, for example, in this page, if we use if for whether or not to buy more gas in the purchase column, using safety stock criteria, which we compare with the current volume in column K, we will get a decision where we either purchase 25,000 barrels or not. And here is the clean version of the Excel of only the pages we need to upload into the database and the web app. So we picked out of all of this, all the sheets in here, we picked only a specific few to upload into the database.